quadratic functions. Oh my. Well, anyways, YouTube, this is an essential guide to quadratic functions. I mean, they're pretty basic, but you gotta know this stuff, so might as well cover it, right? The quadratic equation formula, you apply it basically when your function looks like this. Ax squared plus bx plus c, okay? So, when your function looks like this, you apply the following formula, okay? You use the following formula when all three terms are given. Memorize it, darlings. It's important. Okay, here it is. X equals negative b plus or minus radical b squared minus 4ac over 2a. You're going to use this a lot, okay? Like, a lot. So, your best bet, memorize it. Okay, so let's apply what you learned. Alright? Let's use this problem. Radical x squared minus 3x minus 4. Okay, step 1. Remember what's beneath the radical must be equal or greater to 0. So what you do is that you set the equation equal to 0. Okay? So you get x2 minus 3x minus 4. And it has to be greater than or equal to 0. Alright? Now you substitute these values into the formula. Okay, a equals 1, b equals 3, and 4, and c equals negative 4. Okay? And it'll look like this. Negative 3 plus or minus radical 3 squared minus 4 times 1 times negative 4. Alright? And then negative 3 plus or minus radical 9 plus 16 over 2. Alright, this will give you the following answer. X equals 3 plus or minus 5 over 2. So this means you pretty much have to solve it twice, alright? Because it's plus or minus, so you have to do it for the plus and you have to do it for the minus. Remember, because the value is x squared, there are two holes in graph, a positive and a negative, alright? So, 3 plus 5 over 2 equals 8 over 2 equals 4. So x equals 4 is one value, alright? And then for your next one, x equals 3 minus 5 over 2 equals negative 2 over 2 equals negative 2. X equals negative 1, alright? So these are your two values. So here's what you do. You need to know if the value is in the domain or if it's not. So let's start with negative 1, shall we? You get a number that's less than negative 1, so it's to the left to find out whether it's positive or negative, and you put it into the equation. So let's use the number negative 100, alright? Go to the original function. Negative 100 times negative 100 equals well, it's a big number, okay? But it'll be positive. Minus 3 times negative 100 minus 4. It'll still be positive because this number is so overly large, alright? Even within the radical. So you know that a value that's less than negative 1 will be positive, alright? So now use a number between negative 1 and 4. So for example, use the number, I don't know, 2. 2 times 2 is 4, minus 3 times 2 is 6, minus 4. And then when you radical that, it'll be a negative number. So you know that a number between negative 1 and 4 is not in the domain because it's negative. Alright? And now use a number greater than 4, 100. 100 times 100 minus 3 times 100 minus 4. Radical. It's still positive. So a number greater than 4 is positive. So step 3, or whatever step we're on. It's basically what we did, but this is a more, like, better explained. Find a number ridiculously smaller than negative 1, like negative 100. Substitute that into original equation, like that. The value is positive, so domain before negative 1 is positive. And then find a number between negative 1 and 4, like 3. Substitute it into the equation. 3 times 2 minus 3 times 3 minus 4. 9 minus 9 minus 4 equals negative 22. Because the number is negative, the range from negative 1 through minus 4 isn't part of the graph. So it's a hole. Okay, so we pretty much found the domain now. The domain is negative infinity, 1, negative 1, union, 4, infinity. Okay, let me explain to you what these brackets mean. This means that infinity isn't directly included, but it goes to infinity. So that's why it's a closed bracket. And then this bracket means that -1 is directly included in the answer because we specifically did use the number -1. And so this is half of the range, and the union means this is the other side of the range. Okay, 4, open bracket, infinity, because the 4 is directly in the domain, and the infinity is not. So this is your range. And verbally, this basically just says all real numbers from -infinity to -1, and all real numbers from 4 to infinity. Okay? So that is your range. And that is how you solve quadratic.